So today what we'll do is, as you are aware, we have extended this session. We are doing it for till 12:10. Okay. So today what I'll do is, initially I'll cover some of the regular Java stuff. We'll cover the following. We'll cover what is a inheritance in Java, overriding, overloading, and then we'll talk about abstract classes, and then we'll talk about final classes, and if time permits, we'll go into interfaces. Okay. But as I said again, unless you code with us, you will not explore the new ideas and things. Java can be learned very easily by just doing a bit of experimentation. So we'll start. We'll start with inheritance. So we'll create a class. Today I'll create only dummy classes. After that, just to explain the ideas. And once we start taking up applications, which we'll do in the second part. Today we'll have another part where we'll do the lead code kind of exercises to see, because that part has to develop. We need to have our coding well developed, but that we'll do in the later half. So we'll start with creating a class and learning how to extend it. So I'll keep my class very simple. I'll not add too much frill to the class. So as usual, we'll import java.util.star. Now we'll start with a base class so as to give us something to play with, and we'll quickly understand what is an abstract class, what is inheritance, what is overloading. These are in deep coding, not in this. So we have class base. We'll start with class base, okay? And we'll create two state variables, int x and int y, some two state variables. Let's create a string also. So string z, could be anything, okay? And then we are going to write a constructor for this class. You know how to write a constructor. What is a constructor? Same name as the name of the class and no return type. Okay. So we'll have a constructor which takes 3 parameters, int a, int b, and string c, and then it will say x equal to a, y equal to b, and z equal to c. Okay. Now before I start talking about inheritance, I will write the main, which will drive the thing, which has to have the same name as the name of the file, and that class has to be public. That's the driver class. So we'll write that. So class test. So we are calling this file test.java. So this class actually ought to be public. I don't know whether our tesslator compiler allows it to happen, but let's mark it public nevertheless. Okay, so we have public. Now you are going to help me understand what's going on, and we'll learn as we do. So now I will say base b is equal to new base. Will this line compile? Line 15 as it is without any change, will it compile? I'm not asking whether it will run or not, and try to answer without doing it. Will it compile? Yes? Everybody says yes? Okay. The answer is no. Can you tell me why? Huh? Sorry? Base class is? No, base class need not be public, no. So what's happening here? Let's now understand what's happening. Okay, it's not going to compile. Reason is, if you look at that line 15, what do you see there? You see me invoking a constructor, right? So I'm trying to create an object on the heap. All objects using new in Java are created on the heap, like malloc, but everything is created in Java using that. So now what's happening is, I'm asking a base object to be created on the heap, but the problem with Java is, Java says, I have one constructor which is there, and that constructor, fortunately or unfortunately, takes 3 parameters, and you have given me none. Okay, but now it will give you this error. So let's understand the error, and then let's do something, and we'll understand it some more. So we see an error message. Java error messages are notoriously bad. So what's happening is, it's saying you are not giving me a constructor. You're calling a constructor, but I don't have such a constructor. the constructor that I have needs 2 ints and 1 string, which you are not giving me, and therefore I don't know how to create a base object. That's the error, and I am seeing that error. Okay. Now, if I were to turn it back to you and say, I'm not going to change line 15, I don't want to change line 15, please listen carefully. I don't want to change line 15. I want to leave line 15 as it is, but I want this code to compile. What should I do? Sorry? Create a new constructor? I don't want to create a new constructor. What should I do? I'm sorry?
You static in the beginning and first initiate.
No. I don't want to do something very elaborate.
What values?
No, I don't want to give default values. By the way, defaulting is troublesome in Java. It's very easy in C++. Yeah, so I'm going to do this. Maybe I'm looking for an answer which I only want. Okay, so I'll do this. Now, everybody clear 15 is not compiling? Yes. Now I'll go to line 6 where my constructor is, and I'll do a bit of surgery. I'll comment out that constructor. Will it compile now? Why? Yeah. So the rule I'm trying to get at is, if you don't give a constructor, then Java takes pity on you and gives you a default constructor, which initializes all variables to 0 or null, depending on whether they are string or integer. If it's a boolean, it would have got initialized to false. So because now I took away the constructor, now this line is going to compile because Java has given me a constructor. So the 0 parameter constructor which Java gives by default is given only if I do not have any other constructor. If I have a constructor, Java says you have a constructor, now I am taking away the default constructor. Now you either write the default constructor on your own or call the appropriate constructor. Okay. So now I try to compile this code. This code is going to compile. Okay. You see there, it's running. It is not printing anything because we are not showing anything, but the code is compiling and running. Are we clear? Do you understand what happened? So we understood a very important rule of Java. Java gives me a default constructor and I don't have any other constructor, right? Only then Java gives me a constructor, and if you have a constructor, Java doesn't give you a default constructor. Okay, so we'll move on. So now we'll bring the constructor back and decomment. Now this line won't compile, line 15 won't compile for obvious reasons which we just saw. Now, can we have 2 constructors in a class? No, yes? We can, right? We can have as many constructors as we want. So let's add yet another constructor, but before that, let's just put a line in our constructor, line inside the constructor, saying system.out.println, 3 parameter constructor called. 3 parameter constructor of base called. Constructor of base called, because we are going to have to mark this because we are going to play with it a lot. So 3 parameter constructor of base called, I have put that line. Okay, now we'll go back and add another constructor. So we'll say base, now we'll create a 2 parameter constructor. So we'll say int a comma int b, 2 parameter constructor, and what it will do is it will initialize x to a and y to b and leave z uninitialized. So z will be null. If you don't initialize something and it's a object reference, string is a class, so z is an object reference. So because it's an object reference, it will automatically get initialized to null, not to 0, not to false, to null, because that is how Java behaves. So now, and we are putting a line there called 2 parameter constructor called. Okay, now it's obvious what will happen. Come down. Okay. Okay. Now this won't work. Line 23 as it is won't work. I need to pass appropriate parameters. So if I pass 2 parameters, the 2 parameter constructor will be called, and if I pass 3 parameters, third one being a string, I will have the 3 parameter instructor. That's fairly easy to check. So we'll just pass 2 fixed ints, 10 and 15, or 10 and 20, and run it. So we will see what gets displayed. So as expected, we have 2 parameter constructor of base call. That is not a surprise, that is nothing great there. So what we are seeing now is called constructor overloading. We have overloaded our constructor, sometimes with once with 3 parameter, once with 2 parameter. This is called constructor overloading. You can do method overloading also, we'll do that in a moment, and it's the situation which decides which constructor will get called. Okay. Now what will happen if I do this? Can we come to main again? What will happen if I say 20.5 F without space, without comma, just 25 F. Why did I put a F there? Because I want it to be treated as a float. Now, will this code compile? Will this code compile? No, obviously not, because though I have a 2 parameter constructor, what is my problem? My problem is I have a float and my second parameter is an integer. In my constructor, my second parameter is an integer. Now a float cannot become an integer, correct? Because float is a fat guy. Though float also takes 4 bytes, integer also takes 4 bytes. But float is regarded as bigger than an integer. Why? Because the ability of float, because of the, how float holds its values, there is you must have studied this, there is something called characteristic and Mantissa. Are these words familiar? Or exponent, people call it exponent. There is a base and exponent. Some people call it characteristic and Mantissa. Some people call it base and exponent. Because in a float, you have a base and ability to hold a exponent also. Obviously, the value which a float can hold is far bigger because it's 10 to the power of something. There is an exponent part to it. So the value it can hold is far bigger than an int. So what I am having on line 21 is I am having a float, and float can't become an int, correct? Can an int become a float? So let's first get this error. You are getting an error because that constructor is not working for you, and it is saying possible lossy conversion, and it stops. Why is it not working? Because a float cannot become an integer. This error has a specific name. This is called a narrowing error, because what is happening is we are attempting to narrow a float into an int. Java does not tolerate narrowing. Narrowing is not allowed. So in fact, no language tolerates narrowing except C. C doesn't care. It just truncates and takes it. That's why nobody uses C. So 20.5 F cannot become an integer because Java says it's not possible for me to convert a float into an int. Let's try the vice versa. The vice versa is we are going to pass an int and we are going to declare our second parameter of that constructor, line 12. We are going to declare that as a float. Okay. I don't think we need to change anything. Yes, no. What kind of story do I have? I have a 2 parameter constructor, but my constructor takes an int and a float. Can you see that? And it says 2 parameter constructor called, fair enough. Now, what am I going to call it with? This is no brainer, right? 21. Because I am passing a float and all that, that should not be a surprise. Anyway, that constructor will get called. Will this work? 100% it will work. It's not a narrowing, remember? It is a widening. Why is it a widening? Because int, though 4 bytes, float also 4 bytes, int is treated by Java as a smaller data type than the float, because the value which an integer can hold is smaller than the value of float can hold because of the exponent. So this will be allowed. The reverse is not allowed. Widening, Java has no problem. He says dubla guy can go through a bigger door, through a door, but a fat guy can't come through a door. So sometimes they manage, sometimes they don't, right? So you can't get in. So that's the same problem. Narrowing is not allowed. Widening is okay. Widening has no issue. So you'll see here we have a widening because we have a float there and we have a int here. So we'll run it and see that it works. There is some other error. So we'll declare that as float. That was a mistake. Okay. Yeah. As expected, we'll get a 2-parameter constructor called if you run it. Yeah. We have a 2-parameter constructor called. Is everybody clear? Widening is allowed, narrowing is not. Now in order to understand widening and narrowing, what is the order of the data types in Java? The order of the data types is very simple. What is it? Smallest data type is byte. After byte, char. Char in Java, I told you, is 2 bytes because it's a Unicode supported. It supports all languages. So char is 2 bytes, short is 2 bytes. Char is used to store char, short is used to store small numbers. Byte is 1 byte, char is 2 bytes, short is 2 bytes, long is 4 bytes, float is 4 bytes, but long is smaller than float. Byte, char, short, int. I said int is smaller than float. Okay? Int is smaller than float because int can hold float can hold a bigger value. Then comes long. What is the size of long? 8 bytes. Double is also 8 bytes. Okay. But double is bigger than long. For the same reason, float is bigger than int because double can also store exponent. So that's why double is longer than int. Okay. Now, there should be something interesting to try. Can you come down a little bit? Now, we will create 2-parameter constructor. We'll call this constructor 2-parameter constructor. Just change the text there in 2-parameter as and say after the number 2, say int plus float. Just put int plus float. Okay. So this is the constructor which is called. Okay. Now we'll introduce another 2-parameter constructor which takes 2 ints, pure ints as parameters. So we have now int and int, and I don't see any problem because an int can always be assigned to a float. Okay. Now, in this line, now on line 27, which constructor will be invoked? Which constructor? First of all, will it compile? No. It will obviously compile, there is no error. You can have as many constructors as you want as long as they vary in either the number of parameters or the data types of the parameters. Any of these 2 variations are fine. You can vary in the number of the parameters or vary in the type of the parameters. Number or type, any variation is fine. Here, if you see the constructor I have on line 18 and constructor on line 13 and 18, if you consider, constructors are 2-parameter constructors. You are with me? One of them takes an int and a float, the other one takes an int and an int. So the variation is not in the number of parameters, the variation is in the type of parameters, which is completely acceptable, okay, correct. Now, when I say line 27, I am invoking the constructor with 2 parameters, both are int. What will it use? It will use the more precise one. If I comment out that, it will use the earlier one. Okay, let's demonstrate that. You have to learn to play with all this and check it out on your own. This is the language. Okay, so you see, now because I passed 2 ints, Java chose the int plus int constructor, the more precise constructor. Now if I remove that constructor, okay, or suppose I change it to 20.5, then it can't call int plus int. The more precise constructor in that case is int plus float. So, okay, no, before that let me make a mistake. Okay, I will just say 20.5. No, remove that F for a moment. Will this code compile? Please think. You have to be careful in Java about everything. Java is a very strict language. You have to understand each line, what is its implication, why is it happening. Now, will it compile? No. Why? Because now Java will treat its parameters as int and double. And we have two constructors, one which takes int and int, other which takes int and float. Correct? Now, both these constructors cannot be used in this instance because I need a double. Double cannot become a float. Double obviously cannot become an int also. So, this is again a narrowing problem. This is again what we classically call a narrowing problem. Narrowing is not allowed in Java ever. Okay. So, we'll get again a narrowing error. Let's get that error. Okay. So, there we are. So, you can see what it is saying. He's saying int float constructor is there, but I cannot use it because 20.5 by default is a double and I can't fit a double into an int. Double into a float, right? He's not looking at int and int obviously, he's looking at int and float, and he's saying I can't do this because you've given me a double value. 20.5 by default is a double value, not a float value. Now, if I want to change that, if I want this to work, I can do one of two things. I can do one of two things. One is I can do 20.5f, right? If I say 20.5f, the compiler has no problem with this because he says, yes, I do have a constructor which takes an int and a float as a parameter. I can use that because you are giving me a float. Or there's another way I can do it. I can go up and add another constructor for int and double. Okay, I can do that. So then even if I say 20.5, that constructor will be chosen, right? So in this case it will work and we'll observe. Okay, now this is going to compile and work. I hope you are trying with us. So as you can see, the constructor which got called was 2 int plus float parameter constructor of base call. Everybody clear? Now at this stage I want you to be clear about two things. One, what is constructor overloading? A. B. How is a particular constructor chosen? By matching. It goes with the closest match. If closest match is not available, it does widening. It can never do narrowing. Okay? Like if you call now with 2 ints, it will go for the int. But suppose I have a constructor which is only int float and I call with 2 ints, it will still work. Why? Because int can become a float. Float cannot become an int. Int can go into a float easily, no problem. Okay. So we have this 2 constructors and we have the base class and we have worked a bit with the constructors. Now we are going to elaborate this little further. What we are going to bring in now is inheritance. Okay, and then we are going to play with inheritance. We know how to create a class. We know how to write a constructor for a class. We can write many constructors. We are also reasonably clear which constructor gets called when, correct? Now what we are going to do is, we are going to add a bit of inheritance and see how inheritance works in Java. The inheritance of C++, I am hoping some of you at least know a little bit, and we are going to compare it with the inheritance of Java. You should have this clear perception in your mind because there are some very salient differences which happen between Java and C++ as far as inheritance is concerned. So let's start exploring the inheritance. Okay, we'll go to inheritance. So we'll write a derived class. So see the way we create a derived class. Very easy. In C++ we have the colon and that is how we create the derived class. Java is a little more explicit. It says extends. Okay. So I'm going to create a class called derived. Okay. Class derived extends base. What am I saying by that line? That I am creating a class which is derived from base and I am calling it also derived. Okay, whatever, I can call it whatever I want. So class derived extends base. And what is the philosophy of inheritance? All of you know this. I want to become rich, not by my own effort. My father was rich, so I am rich. So class derived, but the philosophy is true in Java inheritance and C++. I should get whatever behavior my base class has. So why do we have this idea of inheritance in languages? Very often people create code and encapsulate that in classes. Now, I am the guy who came later and I want to create a class. I realize that there are so many classes around me, and a lot of those classes have more or less the similar functionality. I have two options. One, I can rewrite that class, reinventing the wheel, or I can derive from that class, or I can copy code from that class. So what I say is, that class is good, let it be good. I like most of what the class is doing, except I want to add a little more behavior or a little more modification to the existing behavior. So any of these two options I want to do, I will use inheritance. I am repeating again. Why do I need inheritance? I have a bunch of classes or a single class which has a lot of the functionality which I am seeking. I want this class to do what, for example, in the world of animation, it already knows how to play itself, it knows already how to move, it knows how to jump. All this I like. That I have a class and I want to just tweak it a little bit. Tweak may be not a right word. I want to modify it, I want to enhance it a little bit or a lot. So I should not start from scratch like reinventing the wheel. I should borrow something, take something and do it. Okay? So for that, before we go to derived, I think, let's add some behavior, some small behavior to our base. After the constructors, let's add two methods. These are just dummy methods. I am showing them just to show the mechanics of the language. We'll add two methods. We'll call one M1, we'll call one M2, just so that we know what all happens with that. So we'll have void M1, and it has a very simple line in it saying system.out.println M1 called. Now let's not worry about what this M1 is doing or supposed to do. It's not important for a language point of view. So we'll say M1 called. M1 of base called. Okay. M1 of base called. Are you with me? And we'll add one more method just for the heck of it called M2. It will say M2 of base called. Is everybody with me? I have three constructors or three constructors in base. Yes? No, yes. You have two methods, M1, M2, and please put those SOPs in them saying M1 called, M1 of who called, M1 of base called, M2 of base called, so that you know how the mechanics work. Okay. Yeah, now I'm going to create class derived extends base, and I'm going to create one more variable there for the sake of creating a variable. Let's say int k. Okay. This is a state variable of derived. Okay. So remember, base has three variables, x, y, and z, and this guy has an extra variable k. Okay. So now I will say in derived I'm going to add a constructor derived. It is a single parameter constructor. Let's say int a, and I'm going to say k equal to a, and in that I'm going to say one parameter constructor of derived called. One parameter, because it's a one parameter constructor. So we are putting that. So it's a one parameter, it's just an int, okay, of derived. One int. Are we clear what we are doing with derived? No, yes. Everyone clear? Class derived has one constructor, one state variable, and we are saying whatever got called. Okay? That's it. Okay. Now, I am going to say this. Okay, let's go down 39, 40. Like add one line 40. Now I am going to say derived D. So I am trying to create an instance of derived class. Derived D is equal to new derived 5. Now, please don't try out. Now tell me see, I have in the derived class a constructor which is having a integer parameter. I am sure you can see that, correct? So now, my question is, will this line work? Will this line 40 work? Will it compile? Don't do and tell me. Will it compile? Yes. Java is very tricky. There are more no's than yes. Okay. So the answer is no. It won't compile. Now you'll ask, what the hell? Don't I have a constructor which is having an integer parameter? Just now you said base was not compiling because it didn't have a parameter which was appropriate. Now it has an appropriate parameter. Why is it not compiling? Now there is a reason it won't compile, which is what I am going to elaborate. Listen carefully. Whenever, please understand this very clearly. Whenever I create a derived class object, sitting inside a derived class object, there is also a base class object. In essence, a derived class object cannot be created without creating its base class component. So, if you visualize in your mind a derived class object, how much of data members does it have? It has 4. Why am I saying 4? 3 which it inherited and k which it added. So altogether 4 variables are there, out of which 3 are with base, which is its base class, and 1 is with derived. But you can't create a derived object sitting inside, think very clearly, sitting inside every derived object there is a base object. In this case we are calling it derived and base, right? It cannot be that you can create a derived class, an object of the derived class without creating a derived object, without creating a base object. It can't be, it can't happen. Okay. So now the dilemma in front of the Java compiler is, as far as creating the derived object, it sees no problem because there is a nice constructor there which you have given, which takes an integer parameter. But the problem now is, there is this base object. So the base object also has to be constructed. Memory has to be given and an appropriate constructor has to be called for the base object which is sitting inside the derived object. I am not talking about the base object on line 39, that is a separate thing. I am saying that line 40, which is creating a derived object, internally also has a base object. Now the dilemma in front of the Java compiler is, I know how to create the derived object. My problem is, how should I create the base object? Tell me how to create the base object. Why is that a dilemma? Because you see, there are 3 constructors there for the base object. Can you see? We added 3 parameter constructor and 2 parameter constructor. They are all there. Now the dilemma in front of the Java compiler is, I can create the derived object, but for that I need to create the base object. And when I create the base object, I need to supply and call an appropriate constructor for the base object. Now which one should I do? Should I call the 3 parameter constructor? Should I call the 2 parameter constructor? Or should I call the other 2 parameter constructor? Are you understanding? Because Java compiler is confused. I don't know how to create my base part. Which constructor do I call for my base part? How do I know? You are telling me, okay, derived class constructor you are giving me, but I have to create the base part. Which constructor should I choose? I don't know. And therefore I will not allow this line to compile because you are not giving me any suggestion, any clue, any guidance as to which base class constructor I should invoke. Okay. Okay. Now just try this, you will get an error. Okay. As expected, we are getting an error. So the error is, there is some problem with the base class constructor. It is not able to find an appropriate base class constructor. You see the error. You can try to read the error. There is no base class constructor suitable. So there are 2 ways to solve this. The first obvious way is, I can write a default constructor for the base class, or I can remove all the constructors of my base class, which is exactly the same thing. I am sorry, I will repeat again. There are actually 3 solutions. The first 2 are, I can get rid of all the constructors in the base class, I can comment the 3 constructors in the base class. Will it compile then? Yes. Why will it compile? Because then Java in its great generosity will bestow on the base class a default constructor. Yes? Because I have removed all the constructors. So Java feels I will give him a constructor, and then there is no confusion because obviously there is no constructor, so it is the default constructor which is getting called. Correct? One solution. Yes? Second is, I can, in addition to those three constructors, supply on my own a default constructor without any parameters. Then that will get called. Because when Java gets confused, it looks for the default constructor. It's not there right now. Either you can supply it or you can comment out existing constructor and it will compile. You want to try that? Okay, we'll comment out all the constructors. You see there? We'll comment out all these three constructors, gone. Now you'll see my code will compile like music, right? Yeah. Earlier line has an error. We'll comment that line for a moment, that base object. We'll comment that line. Okay. Now, absolutely no problem, and it is calling the derived class constructor. Are you seeing that? No, yes. Is everyone convinced what happened? You have to understand what happened. What happened is, because I comment out all constructors of the base class, the default constructor kicked in because Java gave it. And now, what is getting invoked for the base class construction? The default constructor is getting invoked because I didn't supply it. You can also supply it. Nobody stops you. You can write your own default base class constructor. Shall we do that? You will see that constructor getting invoked. Let's do that. Because it's early days, I want you to be very clear. So we'll comment out, we'll call base, you say, zero parameter constructor of base call. Okay, fine. Zero parameter constructor of base call, so we'll run it. Okay, now we have a base constructor without any parameters. Now see what happens. I have not changed the line below. Okay, I am just showing you. I have not made any change to line 43. So what will I get now? See what you get and understand. Yeah. We will see two outputs, two lines rather. Okay. Does that make sense? No, yes. Now it invoked, because I gave the constructor, zero parameter constructor, it invoked my zero parameter constructor, and after that it invoked the derived class constructor. Because remember, whenever we create a derived class object, first the base class object has to be created, then the derived class object. So it went, now it could create the base class object, it called it with the zero parameter constructor and all. Okay. Now I'm going to go back to the code and we're going to make a small change. I just demonstrated that. Now will my line compile? No, yes. Line 43, will it compile? No. We cannot. We can compile? Line 43 can compile? No. Why? No zero parameter constructor. Okay, because I have written three constructors. They are all there. Can you go up? Okay, so if I had not written the zero parameter constructor, there is no default zero parameter constructor. You know the rule. Because Java, I wrote constructors, Java did not give the zero parameter constructor. Okay. Now, suppose I want the code to compile. In this case, what should I do? Okay. Now, we introduce a word. This is a magic word of the Java language. Okay. It's called super. Okay. Now, what is the situation? I have three constructors in my base class. And in the derived class, I have one constructor, which is fine. Now, unless I tell Java that you should use a specific constructor of the base class, it is going to go for the default constructor. Correct? And that is what is happening right now. And if you give that constructor, it will work. Or if you remove all your constructors, which is going back to the default constructor, it will work. But the moment you have three constructors and you don't have a zero parameter constructor, it won't work. Because that is the constructor it looks for by default. And I don't have that right now. So I have, however, three constructors. So what is my business? I should somehow guide my Java compiler while creating derived class object I should choose him, I should tell him, Baba, don't look for that default, enough. I will tell you which constructor to call. How do I tell? Using the word super. Super means base class or super class. Super class is always referred to as the base class. So I am now going to write a line. Just watch this line. I am going to go to derived class constructor, line 35. Okay. After that, as the first line, I am going to say super 10, 12. Okay. Are you understanding what I did by putting this super? Super is a reserved word of the Java language. What did I do? Do you understand what probably is happening? Now, yeah.
It calls in parameter constructor.
Correct. So I am telling the Java compiler that when you create the derived class object, when you call the constructor for the derived class object, you first create the base class object, but now I am telling you which constructor to utilize for initializing the base class object. The constructor that you ought to use is the constructor which takes 2 int parameters. Why am I saying 2 int? Look at my line 36. Am I not saying 10, 12? That is, I am telling the Java compiler, use a specific constructor for creating my base class object, and that specific constructor is the one which takes 2 parameters, 2 int parameters. So now my Java compiler feels very happy. Oh, he told me how to create the base class part. Though there is no default constructor in base class, in the derived class constructor he has given an ample indication that you please utilize an appropriate constructor of the base class and invoke the derived class. So now you will see the compiler will not have any errors, and you will see what you will see. We'll run it. Okay, now you see compiler is happy. Did you understand what happened? The 2 ints got called, yes, and then the derived class constructor got called. Correct? 2 ints and the derived class. You know what happened. Okay. Now, suppose on the contrary, I want to not call this specific constructor. I want to call a 3 parameter constructor. What should I do? Pass 3 parameters of the appropriate type. Correct? So now let's try that. Let's see the 3 parameter constructor. The constructor needs a string as its third parameter. So I can pass some string, let's say KMIT. It has no effect on the program as such. Now, will the compiler be happy now? No, yes. Yes, no problem. Because now I have indicated explicitly which constructor to call using the super keyword and the type of parameters. So now you will see, as expected, the 3 parameter constructor of base called, that is the 2 ints plus string, that constructor is getting called, and then the derived class constructor is getting called. Are we clear? Yes, no? Okay. Now we will look at, this is the first thing you need to understand about derived objects. That is derived objects from a base class. What is it that you need to know? You have to be very clear how many constructors are there in the base class. When creating the derived class object, you have to be extra careful that which constructor you want for the base class, you have to choose using the word super. Now a small point here is, super, when it is used in a constructor, has to be absolutely the first line. Meaning, if I go to the constructor and try to reverse these lines, that is, I try to put this after k equal to a, then again my code won't compile. Why? For a constructor, the super has to be absolutely the first line. Why? Because you see, you have to first create the base object. The base object creation itself requires a constructor. Then you can do something. Your Panchanama can start only after your base object is fully created. So you can't put k equal to a before, k equal to something before. You are done with the creation of your base class and its constructor invocation. So now immediately it will give an error saying Yeah, no suitable constructor found, because now it has to first create the base class before it enters this code. It is not finding any super keeper. It is looking only at the first line, not seeing super. So now it's looking for the default base class constructor again, because it's saying I don't have a super line, I can't see it, it's line, it's only seeing on the first line. I can't see that line. So I'm looking at give me the constructor from the base class which is 0 parameter. Back to square one, right? Because I am not, the super line is not having any effect. So this is not acceptable. So super has to be absolutely the first line only in constructors. So I'm going back and saying super. This will work, okay? Is everyone clear about the use of super? And why do we need super? Yes? Shall we move? Okay, now we move on to, we have just talked about overloading of constructors. Now we will go to an interesting idea which has a fancy name called overriding. Okay, but let's understand it at a core and then proceed. Okay. Okay. So we will start working with our derived class a little more. Before that, okay, let's now line 45. Okay, I'll say, first tell me with this, whether this line will work or not. I am saying d dot m1. Will it work? Will it work means it will run. Will it run? Yes? No? I told you, first say no, then say yes.
Excuse me, sir. Sir, where will be the reference of the base class object, sir, in the program?
Inside D. You will never be getting access to it. If you are creating derived object. That's what you are asking, right?
Yes.
No, you won't get a reference to base, ever. It's referenced only through D.
Sir, then garbage collector will not collect.
It will work because Java knows where to garbage collect. Okay. But you will not get direct access to base. The only way you will get is through super. I mean, whatever limited access. Okay. If you are seeking a reference to base, not direct, through super. This way and one more way. Okay. So anyway, before that, line 45, will it work? Yes, no? It will work. 1000% it will work, because that is the whole purpose for inheritance, isn't it? Derived class does not give M1, but derived is derived from base, and base does have M1. You are with me? So otherwise, if D dot M1 cannot happen, what the hell did I get out of inheriting? Yes? I inherited for no reason. Are you with me? I should be able to get the behavior from the base class. That's the purpose of inheritance. So I should be able to say D dot M1, correct? Okay, let's do that and see. Okay, so if you expand it and check, are you happy with what you are seeing on the screen? Is it what you expected? Construction is, forget it now. M1 of base called. Obviously, there is M1 only in base. It's not there anywhere else. Yes? Everybody clear? I am inheriting it. M1 is a method in the base class. I am derived from base class. I have extended the base class. So I should get M1. Okay. Similarly, I will get M2. Yes? No? Same way. I don't have to show that. Okay. Now, I am going to do a small change there. What am I going to do? I am going to have my own M1 also. Meaning, the derived class is going to have its own M1. Are you with me? Okay. So, we will say void M1 also in derived class. Okay. And I will say, I will pick up a printf. I will just add M1 of derived call. Okay. Now the topography is what? I have M1 in base class. I have M1 in derived class also. Both same signature, same method, no return type, no parameters, exactly same method. Only thing there I am saying M1 of base called. Here I am saying M1 of derived call, just to indicate. Now I am asking you a question, go down. In line 48, now, line 48, which M1 will I get called? Derived or base? Derived. Why? Okay, let's ask this little differently. Okay. Let's ask this differently. If I had established a similar inheritance in C++, what would have happened? Which M1 would I have called? They are also derived. Don't get swayed by the way I ask the question. You think for yourself and tell me. In case of C++, had I established a similar inheritance, derived is derived from base, and had one M1 in base and one M1 in derived, in C++, what would I have got? I would have got derived. So, in C++, if I do this, same situation, similar situation, of course with the language being little different. What would have happened is, when I say D dot M1, it is, no, you're right. It is the derived class M1 which will be getting called. So, you're right, okay. I wanted to just probe a little bit. So, D dot M1 will be derived class. I will come to the change in a moment, okay. There is a small issue, you will see. Okay, let's confirm that D dot M1 is getting called, meaning M1 of derived is getting called. This will happen both in C++ as well as in Java. Always, whatever D is, what is D? Derived. M1 will be called from there. So let's confirm that. Actually, I should have put a C++ compiler also next to it. Okay, let's run it. Yeah. So, no brainer, M1 of derived called. Okay. Now, there is a twist in this tale. So, D dot M1, no question, it will be called of the derived class. Now watch. Now watch carefully, because I am introducing this idea of polymorphism. Okay, listen very carefully. Okay. Now I am saying, next line, base B. Base B. B1, sorry, that was commented. So base B is fine. Semicolon. Did I create any object on that line? On line 49, did I create any object? No. I did not create any object. What did I create? I just created a pointer, or what we call in Java reference. I just created a reference. That reference is going nowhere. It's just sitting on the stack, not pointing to anything on the heap. So I have created base B. Okay. Now, I am going to write a line. B is equal to D. Is this allowed? In this code, is B equal to D allowed? By what law? Is this allowed or not? First, will it compile or not? Yes, no? Yes. It will work. Even in C++, this line will work, because any object-oriented language, please underline any, allows a base class reference to point to a derived class object. And D is pointing right now to a derived class object. Right? Yes? No? The converse of this is not allowed. We'll see that. But this is allowed. Always remember, please, this comes in lot of code. A base class reference can always point to a derived class object. Absolutely no problem. Okay? It will work. Now, I will say B dot M1. Which M1 will be called? Here. Derived M1. Remember, it's a B, not a D. B is pointing to the D. Or I can also say B is equal to new derived. No problem. Same thing. Base class reference pointing to a derived class object. Do you agree with that? I am saying B dot M1. So I am asking you, M1 is there in base class also, M1 is there in the derived class also. I am now asking you, which M1 should I get called here? will get called here? Derived? Okay. Now comes the question, in C++ what would I have called? Derived? Okay. In C++, if I had written a similar stuff, 1000%, the M1 would be called is from base class, not derived class. Because there is a way in C++ to do this, but we'll come to that. In C++, by default, we have compile time binding or what we call early binding. By default. What is early binding or compile time binding? Now, please understand this. I am now talking about C++. In C++, which method to call is decided by the compiler at compile time based on what kind of animal the compiler sees B as. I am repeating. Listen carefully. In C++, which method gets called is decided by the compiler at compile time, and on what basis? Based on what kind of reference or what kind of pointer the method is called. So, at compile time, if I were to look at line 51, what is base? What is B? It's a base reference. So, C++ will say, it's a base reference and I have to take a decision now. God knows what it will point to at runtime. I am not executing runtime. At compile time, what is B? It's a base reference. So, when you say B.M1, the M1 should come from base class. In C++, if you want to avoid this behavior, what should you do? You should mark the M1 in base class as virtual. By putting M1 virtual as virtual in base class, you are telling the C++ compiler, hey, for this M1, delay the decision till runtime. Don't take the decision at compile time. At compile time, B is a base. If I take the decision at compile time, I will call M1 of base class. But if you put the word in C++ for a method as virtual, then what will C++ do? It will say, okay, for this M1, I am not going to take a decision at compile time. I am going to take the decision at runtime. At runtime, what is B? It's a derived object. If you look at this code, I am making B point to a derived object. So at runtime, if I take a decision, then M1 will come from derived class. But that happens in C++, not automatically. It happens because of the programmer taking the pain to mark that method as virtual. If it doesn't mark the method as virtual in C++, the decision will be taken at compile time, and in this case, B.M1 will come from B only, that is from base only, 100%. In Java, on the contrary, okay, what happens? There is no compile time binding. All binding is late binding. Okay? So we have in Java no concept of compile time linking or anything. That thing they have ruled out, removed. They are saying all decisions will be taken at compile time, at runtime only. No decision will be taken at compile time. So there is no question, there is no need to use the word virtual, because anyway I am going to decide at runtime. At runtime, whatever B points to, I will call the M1 from that. Very simple. In C++, you have to put virtual, delay the decision to runtime, and then it will take a call based on what it is pointing to. Java says no, nothing like that. I will delay all decision making to runtime only. I will decide what to call based on what B is pointing to at runtime. Now, in this scenario, B at runtime is pointing to D. D is what? Derived type. So, it is very clear what method I should call. I should call derived class method. Are you clear? So, in Java, what they call runtime polymorphism is not a magic word that you have to put or some virtual decoration that you have to put. nothing like that. It's automatically runtime. Okay, so it's a late binding. Okay, so you'll see that in action. So watch it. Yeah. You see the answer. Why is that coming? Watch especially the last line. You are seeing where is it coming from. The earlier one, there is no confusion. I am using D.M1. Last line I am using B.M1, but B is referring to D. And the decision is being taken at runtime without any virtual, anything. Okay. Okay. So, are we clear about what is polymorphism here? Now, why do they use the word polymorphism? Okay, let's come here. Okay. Now, who is morphing? Okay, let me just for the sake of doing this, I'll say line 49, change it, base B is equal to new base, two parameters, no? 10 and 5, whatever, something. Okay, then say B.M1. Okay, and comment out 48. Okay. Okay, now can you understand what's happening? On line 50, which M1 will get called? No surprise, no? I am pointing to a base class object, so it will call M1 of base. On line 50, which M1? Base class M1. Then B is equal to D. Then which M1? Derived class M1. Let's confirm that. Okay. See this. Forget the constructors for a moment. M1. Okay. M1 of base called, M1 of derived called. Are you clear? Do you understand why it's coming, what is coming? Followed? Shall we move on? Yeah. So we are getting M1 of base called, M1 of derived called first. Okay. Now our emphasis is on the word polymorphism. Poly is many, morph is many shapes, many forms. Okay. Now let's go back to the code. Now, go to the main code. Do you see morphing happening? You have to see. See with your mind, are you seeing morphing happening? You are seeing or no? Who is morphing? B. B is morphing. B, when it was created, it was a base class object. It was referring to a base class object. And when I called B.M1, at that time, it was behaving like a base class object, and the M1 which was called was obviously from base class. Then, on line 51, B changed its flavor, its form. Now B became a reference to a derived class object. And then when I said B.M1, the same reference morphed from a base class reference to a derived class reference. That is the only morphing allowed. There is one more kind of morphing allowed, but we'll come to that. So in this case, base reference morphed from pointing to a B reference morphed from pointing to a base class object to a derived class object. And the effect of that morphing also you saw. When I said B.M1 earlier, it called M1 from the base class. When I called B.M1 later, it called M1 from the derived class. So the effect of morphing was also seen. There first time one M1, second time another M1 from different classes. Are we clear? So this is essentially what we call polymorphism. This is the crystal clear definition of polymorphism. Ability to change the form based on what you are pointing to. So Java, they say, supports runtime polymorphism. And why do you say that? Because what you just saw. The behavior is described by what we are pointing at runtime, and there is obviously because of that morphing of the behavior. So it's that kind of a thing. Okay. Now, I am going to say this. Okay. Now, a little more elaboration and I will stop with that. We will move on to something else. Now, okay, I am going to comment out line 49 right side, and line for 50 just to remove confusion. Okay, line 50. Okay, we are back to, okay, so we have base class reference B, B is pointing to D, and then we are saying B dot M1. Now which M1 is called? We just discussed. Derived class M1 is called because B is pointing to a derived class object. No surprises. Correct? Now, please listen carefully, don't get exhausted. One more point, and a very fine point now, is this. Suppose, now when I am seeing B dot M1, I don't want to change line 51 at all, or I don't want to change main at all. The M1 is called of derived, because M1 of derived is deemed to have overridden the M1 of base. If I say B dot M2 here, I'll get the M2 from base only, because there is no overriding definition in derived class. Do you agree with me or not? If I say B dot M2, which M2 will get called? No confusion. M2 is there only in base, there is no overriding M1, there is no overriding M2. So if there is no overriding, whatever the M2 which is inherited will be called, correct? Overriding happens when a derived class has exactly the same method as the base class, and you are calling a derived class reference, using a derived class reference, which is what B is. Then overriding will happen, okay? So for M2, there is no such debate, there is no such discussion, correct? M2 will always come from the base class, because in derived class there is no M2. But what if I were to, and this is what I am just now going to say, is a very common situation. Let's go back and think why I wrote a different M1. In derived, why did I write a different M1? Because I don't like the base M1. Remember how inheritance starts, right? Inheritance starts when I take a standard class which I like, which has most of the things I like, and then I am tweaking a little. Now, M2 I left alone. I did not tweak it because I like what base class M2 is giving me. But I did not like the M1 of base class, so I wrote a new M1 for myself. Yes? No? Correct? Okay. Now, what if I were to turn back and say, look, I don't like the M1 of base class, I want to write a new M1, that is what I am doing. However, I also want to use the M1 of base, meaning, did you understand what I said? I don't like the M1 of base, I want to override it, so I am giving a new M1, fair enough. However, in that M1, which I am now giving, the new M1 I am giving for derived, I want to exploit or use the M1 of my base. I don't want to write everything, I want to change it, but I still want the M1 of base. Are you with me? So, that means if you go to M1 on line 40, okay, this is the M1 of derived. It still wants to use M1 of base. Okay. In C++ also you can do that. What you would have written? Base colon M1. No? No, yes. You would have said base colon M1 and you would have got the M1 from your base class. Yes? In addition to your M1. In Java, we do it again using the super, but this time we use super slightly differently. There we use for influencing which base class constructor to call. Now, we go to M1 and say super, super dot M1. I can say now, in a constructor, if I use super, it has to be the first line. Here it need not be. It depends on how you want to use it. You want to use it before, you want to use it after, up to you. Now, do you understand what I am doing? I am giving a new M1 in derived class, but that new M1 still wants the functionality of the old M1 and something else. You are getting me? So, I can use that, though I am overriding, I still want the overridden functionality. It's not that I am completely disgusted with it, I like it, I want to enhance it a bit with the new functionality which is my M1. But I still want to use the old M1. So I am saying, old means inherited M1. So I am saying super.m1. Now I can put that first or I can put that anywhere in M1, I can call super.m1. Unlike a constructor, you don't have to say super as the first word. No, not needed. Okay, so now you will see what happens. Because the way it is written is after the, okay. So you see there, M1 of derived called, M1 of base called. Why did that happen? Because M1 of derived used first system.out.println and then called M1 of base. How did it call M1 of base? By saying super, that is go to my base class and get my M1, get that M1. Yes, no, acha. Now, here is something, okay, which is a little different from Java and C++. Suppose I am a grandson class or granddaughter class. Can you visualize? There is a class A, there is a class B, and there is a class C. In C, so there is M1 in A, there is M1 in B, there is M1 in C. In C, I want to call not the M1 of base, sorry, M1 of B, but I want to call the M1 of A. That is, I don't want my father's M1, I want my grandfather's M1. Are you with me? Yes? Now, in Java, there is a very roundabout way of doing it. We'll discover that soon. But in C++, it's more straightforward. I say A double colon M1. Done. Are you with me? Java, no. You can't say super or super squared. No. The only way you can get is if your father had called his father's M1. That you can't control. Correct? You are understanding? But there is a way, but that is a kind of convoluted way. We will talk about it when we are more mature with the language. Okay? Not yet. There is a way where you can get to your grandfather's M1. In C++, the only point I am saying is it's very easy. Here it's not. There are reasons for the way C++ is that way and the way Java is this way. Okay. But we will not harp too much on it. So we have seen base class, we have seen derived class, we have seen how to create references for base class, use it for derived class. We have seen overloading of constructors. We have seen overriding of methods. We have seen polymorphism. We have compared the polymorphism of Java with the polymorphism of C++. We have seen both the uses of super. One, to engage the appropriate base class constructor. Other, to engage the overridden method. Okay? So that is what we have discussed as of now. Are we clear? These are all I have discussed just in front of you. I am summarizing. Okay, I think we will pause for this because I don't want to overload too much with concepts. So now we will turn to solving a couple of, because that part of you also has to develop. This is what we call the conceptual language, and that is the practical language, use of the language to solve. Okay, now I am going to take a couple of examples. I'll describe to you what that is. Okay. The first we'll open up. Please try and do this. That's the only way you'll learn. The quick brown fox, okay, that's its special. That is called a panagram. It pans the entire grammar. In this case, grammar means the alphabet. Okay, so it's called a panagram. So now we are asking you, we are giving you a sentence, okay, and I'll tell you how to do it. Okay, the quick brown fox jumps over the lazy dog. This is a sentence, and there is another sentence called leet code, which obviously is not a panagram. So you have to read a sentence. How do you read a sentence? You use a next line. Next line will give you a sentence. Now what you have to do is you have to go through the sentence and see whether each letter occurs once. Now you can use various methods on strings which are available to check. No. First of all, you are given a line. Line with space or without space? Without space. Acha, he said na, without spaces. So you'll get a line. So you can do a next also. sc.next will give you a sentence without spaces. So it's a word, let's say. Take it as a word. Now, every letter has to occur at least once. It can occur more than one times. That won't spoil anything. Okay? It would still become panagram. But it has to occur at least once. Each letter has to occur at least once. If it doesn't occur even once, then it is not a panagram. False. Okay. Now, how do you search in a string for a letter? What is the operation? Caret will convert. Caret I will give you just the character. Now, how do you search for a particular word, for a particular letter in a sentence? Which method do you use? Index. Yeah, somebody said index, right? It's a method index. So you'll get familiar with the methods as we go. So let's just go to the documentation and see the index method. String index method Java. You can also see. Okay. Index of, sorry. So index of is used for two things, checking whether a character is there. These are all the various versions of index. Index of S, like that. The string has only lowercase. Now do you understand what is a panagram? Panagram is a string which contains each and every letter. So how will I do it? I'll take the string which the user has read in, and I'll take a string of A to Z. Correct? What will I do? I'll take A, and with that A I'll search for A in the given string. If I find it, I will proceed to the next letter. If I don't find it, I'll there itself return a false. If I am able to cross the entire string and everybody is there, then I'll say it's panagram. Correct? Now this is something, so you have to write probably 2 loops and do it. Please struggle with it a bit. 2 loops and you are done on string. To check whether a string is a panagram. Don't go and look for code on the internet and copy that code. Do it on your own. I've told you how to do it. Index of is the key. Okay, 21 finished. So I will wait another 5 minutes and then we will solve and then we'll go to another question. Once you get a string, create your own string in lowercase of. That's one of the ways you can do. The other ways of doing it also. You create a string of ABCD, A to Z. Take one character from that. So write a loop. Take one character from that string and check whether that string, whether that character is there in this string or not, the given string. If it is there, proceed to the next. So you write a loop. At any point, if there is a character which is not there, enough. It cannot be a panagram. Even if one letter of the alphabet is not there, it doesn't ceases to be a panagram. Okay, we'll wait till 50. Then we'll solve. Someone's code. Okay. So, yeah, this is also a good enough way to do it. Yeah. So here is the code. He's using the ASCII sequence. Nothing wrong. That's perfectly fine. So here is one way. For int I equal to 97. I hope all of you know significance of 97, right? 97 is where small a starts. I mean the small ASCII starts. So if I equal to 97 to 122, 122 is Z, ASCII Z, small z, I plus plus, then convert that from integer to character. That can be done using a casting from I to char. You just cast it, so you become a char, and then check whether index of allows a string or a char to be checked. So very simple. So if s dot index of x, if it is not there, that is the character x does not occur in the string s, it gives a -1. Okay. So if it gives a -1 means less than 0, right? So s dot index of less than 0. At that point itself you can say system.out.println false and exit, come out. System.exit, or you can even say break with some flag. Okay. If you don't exit and you come out of the for loop normally, that means you did not find a single exception. You did not find a single situation where a character is not there in that string. All the characters from 97 ASCII to 122 ASCII are all very much there. That is A to Z, all characters are there, and so you return true outside the for loop. If you want to change it a bit, you could write it like this. You could say, you could create another string, which is what I was suggesting. Can we, we'll just change this program a little bit, add a little flavor to it. You can use. Okay, I think I'll describe it here. Yeah, what I was saying is something like this. String alphabet alphabet is equal to, write A, B, C all the way up to Z. Then just like he is doing this, we will replace this loop by for each char C in alphabet, writing the enhanced for each char C in alphabet. That is, you go through this whole thing, take each character from the alphabet. I think it might work, or this might give trouble. If it gives trouble, then you convert this into array. So char ARR is equal to alphabet to char array. Convert it into array of characters. Then of course it will work. So instead of saying alphabet, you say ARR. For each C in ARR, you check if, so you don't need to do this casting, s dot index of C, if it is less than 0, the rest of the code remains the same. So this is, I don't know whether this is easier to do. This is also fine. This is more like working with an array of characters. This is also perfectly fine. This is also okay. So you take an alphabet, convert it into an array of characters using character array, then go through each character of this alphabet array and check whether that character is there. Even if one character is not there, then the index of will return a -1, which is less than 0. Or you can say equal -1 also, it doesn't matter. And then you say whatever he is doing, these two lines. Okay? Exactly like they are. And then we are done. Okay? So hopefully by now most of you have finished. We can check how many finished. That's too much to expect. About 124 people finished. Okay, even now, which is really fantastic. We'll do one more because this is the way you will learn. Okay, we are opening one more. A little while, just tell me whether it's open. It's called program 3. Day 6, program 3. Yeah, it's a big question, but it can take a little while to do. There are some 2-3 rules, but it will give you good exposure with strings. Okay, it's called Goat Latin question. Read the rules. Don't start writing before you read and understand what we are asking. We are asking something very simple, but read it, patiently read the question, Understand what is happening in the question, then do it. Okay, you are given a sentence, string sentence that consists of words separated by spaces. Each word consists of lowercase and uppercase letters only. We would like to convert a sentence to Goat Latin. Okay, the rules of this language are like this. If a word begins with a vowel, he is telling you what the vowels are. A, E, I, O, U. Append ma to the end of the word. A lot of people in South India have this thing of adding everything with a ma. Okay. So, for example, the word apple, because it starts with a vowel, becomes apple ma. Okay. If a word begins with a consonant, which is not a vowel, he is telling you that also. Remove the first letter and append it to the end. So, for example, goat becomes, remove the first letter, add it to the end along with the ma. Okay, so it becomes, goat becomes oat, G, ma. I don't know, whatever it becomes. Okay, so that is how a word which starts with a consonant becomes. Okay, then there is one more. Add a letter A to the end of each word per its word index, starting with 1. So the first letter gets 1A, the second letter gets 2 A's, and so on. Okay, then, so here is some examples. Okay, let's go down. Okay, now I starts with a vowel. Do you agree? So what will I become? If it is a vowel, ma gets added. So I am A. And how many A's will get added to it? It's the first letter. So it will become I am A and another A. So that's how it became I ma. Yes? No? Okay. Then speak. What happens to speak? It starts with a consonant. If it's a consonant, what happens? The S goes to the end. So peak S. Then becomes a ma. And then because it's the second letter, second word of the sentence, 2 more A's are added. So it becomes peak S ma. Do you understand why there are 3 A's? 1 is coming from ma and 2 because it's the second word in the sentence. Okay. So third, we have goat. So goat becomes, it starts with a consonant, so that G goes to the end, then ma, and because it's the third letter, another 3 A's are added to it. Latin, because it's an L and a consonant, L gets appended to Latin L, then ma, then because it is each letter, it's the 4th letter, 4 more A's get added to it. Okay, now, how are we going to do it? We have a nice string every time. So, whenever you, okay, I'll just describe to you what we'll do. Okay, how we'll do. Okay, then you do, because this is something you can do. First, take the whole sentence. How do you take the whole sentence? Remember, there are spaces in it. What will you use? Next line. SC dot next line will give you the whole sentence along with the spaces. Yes. Now, what you'll have to do? You'll have to chop out the spaces and get the words. How do you do that? Which method? Split. So string dot split, whatever the string which you have read, if you do a split on it with a space as a delimiter in bracket, you will get an array of strings. Okay, so SARR, let's say, is an array of strings. So SARR of 0 will be I, SARR of 1 will be whatever, and so on. So now, what will you do? Now you have got this nice SARR, which is an array of strings. You will go through each word in SARR and process it, depending on what is the starting word and which word it is. So when we say SARR, it is the first word. So we know that we'll have to append 1A to it, but let's keep it aside. That index in that array will help you tell you which word it is. First word, second word, plus 1. Okay, but before that, what is the tricky part? You have to extract the first alphabet. So you can extract the first alphabet. How do you do that? You do caret. Just say caret I, you will get the first alphabet. Caret 0 will give you the first alphabet, first letter. Then you have to check whether the letter is a uppercase, vowel or a lowercase vowel. Okay, you have to judge that. How will you judge that? Well, there is no simple rule. You have to compare it with all 10. Remember, uppercase 5, lowercase 5. You compare all of that. Let's say it's a vowel. If it's a vowel, what do you have to do? Nothing much. You have to take that word which is there in SARR and add first ma to it. Yes? First add ma to it. How do you add? To any string. Each is a string. Just say plus. In Java, if you say plus, you will add ma to it. Okay? Ma got added. Then what other thing you have to decide? How many A's? That will get from the index. Index plus 1, because index start at 0, that many A's. So you'll have to create a string of those A's separately using a for loop internally. Create a string of those A's, and once you get the string of those A's, append that string to the word that you are building. So you got that. Now it's easy to say. Only thing, it's little exercise you will do. Okay, then what is the other thing which may happen? If it is not a vowel, then what do? Then do a substring. Substring, remember on strings there is a substring operation which will take from first letter till the end. Rather second letter till the end. Take that, to that add the first letter which you have taken, the character, add that character to it. Whatever character, caret I gives you the character. Add that character. After that, what do you have to do? Same that, ma and whatever. The last two parts are common. Only for a consonant, you have to do a little more stuff. Okay? The last two are common to everything. That is adding ma and that many number of A's. So that can be a common logic. And only thing is, if it is vowel, you don't have to do anything more. If it is not a vowel, it's a consonant, then you have to take that character, add it to the end and do it. It's not too big a loop. It is about maybe 10 lines. Okay? But nevertheless, so far nobody has succeeded. So, shall we write it? Okay, we'll write it very quickly and we'll be stopping. Okay, you are going to help me write it. Okay. It's very quick. You can write these kind of things. You should be able to write these. This kind of question, 10 minutes is what it should take soon as you become more and more clever with the language. Okay, import java.util.star, class, same name as the name of the class, name of the file. Okay, public static void main. Okay, we got that. Then we create the scanner. Got it. System.in. Okay, what is next? Then we say string. The string which is going to be read in, we'll call it input. String input. The string which is coming from the user, input equal to sc.next line, no? Because it has spaces. Next line. Now we are going to create an array of strings which is after this splitting. Okay, we are going to split. So string SARR equal to 0. What should I say here? The right? Input dot split. I should split the input. Input is a complete thing, remember? Input dot split based on space. Anyway, it splits on the basis of space, but to cultivate that habit, just give a space in the bracket. Okay, so far is everyone clear what we did? No, yes?
Yes, sir.
We have read the input string and we have split it on the basis of space. So I'll get each word of the sentence in SARR 0, 1, 2, 3, so on. correct? Have you understood so far? Okay. Now I am going to iterate through SARR. I am going to loop through SARR for int I equal to 0, I less than SARR, every array. How do I know the size of an array? There is a variable on every array called length. Okay. SARR is an array, so every array has a variable called length. Length, it's a variable. Okay, I plus plus. Acha, is everybody clear so far? No, yes. We have taken the string, split it, we got the SARR, now we are going through each word in that SARR, each word in the sentence. Okay. So, what will I check? I have to check the first char, right? That is an important decision. So, I will extract the first char. So, I will say char C equal to SARR of I, that is the word, dot. Remember, SARR of I is a string. How can I get the first character? I can simply say SARR of I dot char at 0. First character, char at 0. Yeah, does everyone understand line 9? I am looking at the first character. Now I am going to check whether the character is an uppercase vowel or a lowercase vowel, because the treatment is the same if it's an uppercase vowel or. So I am going to check whether it's an uppercase vowel. Actually, I'll check whether it is not an uppercase vowel. Then I have to do something special. Otherwise, anyway, I have to concatenate ma and that many a's, correct? So that's not great stuff. For things which are starting with a consonant, I have to do something special. So I can write a big if, or I can write some nice function, but it comes to the same thing, where I can write a switch case, okay? But I will not do that, I will write a big if, okay? So get ready for a big if. If C not equal to A, should I say now and or? Should I say and or? If it is when does it become a consonant? And or? And. If C not equal to A and C not, all of these have to be true. It should not be this, it should not be that, and then only it's a consonant, no. And C not equal to E, I, O, okay, U, and I can convert it into lowercase and check, but and uppercase also. The whole if right now, put one and scroll, copy, now just make it uppercase. There are easier ways of doing this. Okay. Normally we can form a set of these values and check whether it's not in the set or not. That's the more cleaner way of doing it. Okay. So open bracket. Okay. So let us pretend that it is a consonant. Okay. So if it's a consonant, what should I do? What should I do? I should take the substring from position 1 till the end. No, yes. If it is goat, what should I do? The oath I have to take, no? Oath means O's index is what? 1. Index start at 0. So, I will extract that remaining substring other than the first character. So, I will say string something, sub is equal to what? SARR of I, that is the whole string, dot substring 1 onwards. String sub is equal to SARRI is each word. Substring 1, what does this do? It takes, so if you have goat, it takes oat, it gives you oat. Substring 1 means from the first character onwards, first index onwards. I am extracting that part. Because I am not given a second parameter, substring also has a second parameter. If I don't give the second parameter, it will go till the end of the string. That is what it has done. That's what I want. Because I want to take it from 1 to end. Then what will I do? Sub is equal to sub plus. Okay. Sub plus what? The first character. I can append it. Okay. So I will say SARRI dot SARR of I dot char at whatever that char at 0, right? Whatever that character is. Okay. Are you clear so far? Everybody agrees what I am doing? Everybody understands? What am I doing? If you see this, I am confirming it is not a vowel. After confirming it is not a uppercase vowel or a lowercase vowel. Starting letter is not a vowel. Then what is the question asking me to do? If it is not starting with a vowel, take the remaining part of the string, bring this letter to the end. Yes, that's what we are doing. So that line 11 is getting me the remaining part of the string other than the first character. It is getting me that. To that I am concatenating the first letter, okay, of the original string. And this becomes that thing. So should I now say SARRI is equal to sub because I have modified it? No, yes. So that the rest of the code can be written on top with the use of SARRI. Are you understanding what I am doing? I am modifying it and putting it there because the remaining code is the same whether it's a consonant or it's a vowel. So now I will write the remaining part of the code. Yes, no. I am now writing the remaining part of the code. SARRI is equal to this modified word sub. Yeah. So I will modify it only if it is a vowel. Okay, now come down after the if. Okay. Now, do you understand the way the flow of thought? Flow of thought is that if it is not a vowel, if it is a consonant, I will do some special gadbad. Okay, that is shifting the word to the end, letter to the end and all that. Only if it is a consonant. If it is a vowel, I don't have to do anything. In both cases, what will I have to do now? I have to concatenate ma, and depending upon which letter it is, that many A's also I have to concatenate. So I will take these as two separate activities. So the ma is very easy to concatenate. This one line. So I will say SARRI is equal to SARRI plus ma in double quotes. You agree with this? Do you understand what I have done? I have, in case it's a consonant, I will get the altered SARRI. If it is not a consonant, if it starts with a vowel, I will get the word as it is, no? It will not go into the if. So SARR will stay as it is, each word. Yes, no? Think, okay? So now, what will we do next? We are done with the ma concatenation. Now what we need? We need as many A's. How many A's? As depends on the I plus 1. I starts at 0. So the first word we said has 1 A. So I have to create a garland of A's or a string of A's. How many A's? Depending on my I. Yes. How will I do that? I'll write a small for loop to do that. Okay. So I'll say create we call it a string. a string equal to null string initially. Okay, semicolon, done. Now what will I do? I will build this a string equal to the number of i's. How many i's? I plus 1. Because remember the index is I means one string. Okay. So I'll use another index j for int j equal to 0, j less than I, j plus plus. Okay. What will I do? Yeah. Can you tell me what goes inside this? I am asking. ASTR is equal to ASTR plus A. That many A's you have to add, no? ASTR plus A. Letter string A. Okay, now are you understanding what is happening? So first time what will be? First time I will be 0. So I should go up to I plus 1. I made that mistake. So I should go up to j less than or equal to I. Not j less than I. Right? Less than or equal to I. So first time I is 0. First time I is 0. Yes, no. So j will start at 0. J is less than or equal to I. Yes. So I'll add a. 1a only. First letter only 1a. Sorry. First word only 1a. Agreed or not? Okay. Second time I will be 1. So what will happen? How many A's? 2, no? First time 0, then 1. Okay. So my ASTR is also done. Now what will I do? After the line 19, one last step. What will I do? Huh? SARRI I equal to SARRI plus ASTR. Or you can write plus equal, doesn't matter. Okay. Is my SARRI pakka? Yes? What will I do now? I'll display. I can print, no, this SARRI, I am done. I've done the modification. So I can print with a space. I should always print with a extra space, isn't it? In between space, the sentence. So I should say now system.out.println SARRI plus space. Okay. Done. Okay. Now I'm going to stop here. Okay. I'm going to give you this code. You are going to check whether it works. There may be a few things here and there. Is it working? Check. Okay. There may be a few things which we have to type because we just wrote the code as it is. Yes, no? Works. Okay. So, yeah. Now, we will give you this code. I am saving it. We are giving you this code. Repair it if you can. If it needs repair. If it doesn't need repair, understand what we are doing. Okay? Because I am running short of time, I am doing it. We'll take it up again. Okay. So, we'll give it a shot. Let's see. Run it. Let's see what it produces. First of all, does it compile? Now we have some errors. Substring. Is it substring small? Okay. Try. Caret. It had become chat at. Okay, we'll give some input. I speak good Latin. I speak good Latin. let's see what we get. Oh, we are putting a unnecessary, okay. We are saying system.out.println. We should say system.out.print. Okay, but see the out, okay, changed. I speak good Latin. Make it bigger. So this is what we got. Ma, peaks, again 2 A's after ma. Third is oat, G, M, whatever, A, Latin, again consonant, A-T-I-N, L goes to the end, M-A, and because it's the fourth word, 4 more A's. Okay? So this is how you write code. Now I will giving you this code. You read it at length, at leisure, and then we'll give you some more in the next class. But please read this code and come. Read and understand what we have done, okay, so that you are comfortable with the way it works. The name of the program is Day 6 Program 3 Source Code. I am repeating again, it will be available at home also. Day 6, Program 3 Source Code. Day 6 Program 3 Source Code. Okay, that is the code which is available. Understood? So please read this code, go through it carefully. So read the code and come. Then we can do more, because you have to sooner or later get into this team. Okay, we'll stop here.